Today we are going to learn about the trigonometric ratios with the help of a unit circle. Consider a unit circle here centered at O, and the O is the origin. Mark a point called P with coordinates x and y on the circle. Now join P with O. This is our radius or hypotenuse, and since it is a unit circle, the circle radius will be of 1 unit. Now we will draw a perpendicular. We will call that P to A, and then OA is our base. Let's call it X. PA is our perpendicular, so we will call that Y, and our hypotenuse will be 1. So as we know that the equation for a unit circle is x square plus y square being equal to 1. Now if we want to find the trigonometric ratios, how will we find that? We know that sine theta is equal to perpendicular over hypotenuse. So we can write y over 1 just like I have written here. So y over 1 can also be written as y only. After that, we need to find cos theta. So cos theta is equal to the base over the hypotenuse. So that means it is only equal to x. Then tan theta is the perpendicular, which is y, divided by the base, which is x, y over x. Now we need to find the reciprocals of these trigonometric ratios. So for sine theta, the reciprocal for sine theta will be cosec theta. So you will just swap the values. So it will be 1 over y instead of y. Then for cos theta, the reciprocal is sec theta. So instead of x over 1, it will be 1 over x. And then for tangent, it will be cot theta. So tangent theta was y over x, and cot theta will be x over y. So these are the trigonometric ratios that we found along with their reciprocals. Now, as we know, we have supposed a point called P with the coordinates x and y, as I have written here, and if you look at the figure, that is also shown. But what is the exact value of x and y? Like we found in the trigonometric ratios, sine theta was equal to y while cos theta was equal to x. So we can write P bracket cos theta comma sine theta, because the values of x and y are given as cos and sine theta. So if P is a point of a unit circle centered at O and angle AOP is equal to theta, then the coordinates of P will be cos theta comma sine theta. I hope you guys understood this example. Now we will attempt to find the ratios of 30 degree, 45 degree and 60 degree respectively. Trigonometric ratios of 30 degree. To find the trigonometric ratios of 30 degree, let's choose a point. We call that x1, y1, or you can even just specify it as x and y. It doesn't matter. And that point on a unit circle should be in standard position, such that the angle O will be equal to theta, but instead of theta, we will replace that with the value of 30 degrees. Now we will draw a perpendicular from the point P to the base, which we called PA, or you can call this perpendicular Y, and the base OA as X. As we know, this is a unit circle, so our hypotenuse will be equal to 1. And as in a right angle triangle, the length of side that is opposite to 30 degree is half of hypotenuse. What this basically means that if the hypotenuse is 1, then the value of the perpendicular will be half of that. That means 1 by 2. So as we know, the equation of a unit circle is x square plus y square is equal to 1. So the value of y is 1 by 2. X square plus 1 by 2 whole square will be equal to 1. Now you will simplify this. So that will be x square plus 1 over 4 is equal to 1. Now let's take 1 over 4 to the right side. Its sign will be changed from positive to negative, and then we have 1 minus 1 over 4. So we need to make the denominator same. So we will multiply 1 with 4 over 4. That means x square is equal to 4 by 4 multiplied 1 minus 1 over 4. So what does that give us? x square is equal to 4 by 4 minus 1 over 4. So we can write the denominator only one time, and 4 minus 1 results in 3. So x square is equal to 3 by 4. But we need to remove this square. So in order to remove the square, we will take the square root on both sides of the equation. X will be equal to under root 3 by 2, because the under root of 4 is always equal to 2. Now we have got the value of x and we also got the value of y. So we can say that the point P with coordinates x and y, instead of x we will write under root 3 by 2, and instead of y we will write 1 by 2. But now we will find the trigonometric ratios of 30 degree. In order to find sine 30 degree, what will happen is that the perpendicular will be divided by the hypotenuse. As our perpendicular is 1 by 2 and our hypotenuse is 1, 1 by 2 divided by 1 is 1 by 2. So we can write sine 30 is 1 by 2. Same as for cos 30. What is cos 30? The base divided by the hypotenuse. As we know that the value of the base or x is equal to under root 3 over 2. So if that value is divided by 1, that results in the same thing, which is under root 3 by 2. So that is our cos. And for tan theta or tan 30 degree, because now the value of theta is 30, what will happen is that the perpendicular will be divided by the base, or you can say 1 by 2 divided by under root 3 by 2. So when that occurs, our value of tan theta will be 1 by under root 3. Now these are the main trigonometric ratios or functions, but we need to take their reciprocals. So the reciprocal of sine theta will be cosec theta, and you will just swap the values. The denominator will go to the numerator and the numerator will go below. So that is 2. Same as for sec 30, instead of under root 3 by 2, that will be 2 divided by under root 3. And for cot theta, instead of 1 by under root 3, you can just write under root 3 by 1 or simply under root 3. Now let's move on finding the trigonometric ratios of 45 degree. To find the trigonometric ratios of 45 degree, let's again choose a point called P with coordinates x and y on the unit circle in a standard position such that the angle O will be equal to theta, and that is equal to 45 degree. Now we will draw a perpendicular, we call that PA, and that is perpendicular to the x-axis. Now this triangle that we have, which is triangle OAP, it is a right isosceles triangle. So if that is a right isosceles triangle, that means that the value of x will be also equal to the value of y or the perpendicular. So triangle OAP is a right isosceles triangle. Therefore, x is equal to y. Now what is the equation of the unit circle? That is x square plus y square being equal to 1. So now we will call y x and x as x only. So now we're gonna place the values. X square plus x square is equal to 1. X and x make up 2x square being equal to 1. Now 2 will be divided on both sides of the equation. So we get x square is equal to 1 by 2. But we need to take the square root on both sides. So we will have x being equal to square root of 1 by 2. But if you simplify this, then the square root of 1 is 1, but the square root of 2 will be under root 2. So we found the value of x, which is 1 by under root 2. But if we just found the value of x, that means that the value of y will also be the same as x, because we know that triangle OAP is a right isosceles triangle. So now we need to find the trigonometric ratios. So the sine of 45 will be our perpendicular divided by our hypotenuse. So as we know, our perpendicular is 1 by 2 divided by 1. So that will be 1 by under root 2. After that, our cos of 45 will be the same as 1 by under root 2. But our tan 45 will be equal to 1. That is because the perpendicular divided by the base and both of the values are same, so they result in 1. Now we need to take the reciprocals. So the reciprocal of sine 45 will be cosec 45 and the values will be swapped. So that is equal to under root 2. Sec 45 will also be equal to under root 2 and cot of 45 will also be equal to 1. Now let's move on to finding the trigonometric ratio of 60 degree. As in a right angle triangle, two acute angles are complementary. So in triangle OPA, that will be equal to 30 degree. But how? So first, to find the trigonometric ratios of 60 degree, we will again follow the same steps. We will choose a point which we called P with coordinates x and y on a unit circle in standard position, such that the angle O will be equal to theta and the theta will be equal to 60 degree. Then we will draw a perpendicular which is PA and that will be perpendicular to the x-axis. Now as in a right angle triangle, two acute angles are complementary. What does that mean? That means if you take 90 degree, add that with 60 degree, and here let's assume that this angle is x. So 90 plus 60 plus x will be equal to 180 degrees. So 90 plus 60, that results in 150. So 180 minus 150 is 30 degree. So we can say that the value of x in degrees is 30 degree. That is why we said in a right angle triangle, two acute angles are complementary. Okay, so in a right angle triangle, the length of the side will be opposite to 30 degree and that is half of the hypotenuse. What this means is that if the hypotenuse is 1 or any other value, then the half of that will be equal to the x, which means our base. So as in this case, the hypotenuse is 1, so our base will be 1 by 2 because that is half of that. Now we know that the equation of the unit circle is x square plus y square being equal to 1. So 1 by 2 whole square will be added with y square being equal to 1. Now we have 1 by 4 added with y square, that is equal to 1, and y square will be equal to 1 minus 1 by 4. Now we will multiply 4 by 4 with y to make the denominator same. So the value of y square will be 3 by 4. Now if we take the square root on both sides of the equation, the value of y in the end will be under root 3 by 2. So now we got the values of x, which was 1 by 2, and y, which is under root 3 by 2. So instead of writing p bracket x comma y, we can just write the true values of p. Okay, now we're going to find the trigonometric ratios. As we discussed earlier, the sine of 60 is equal to the perpendicular divided by the hypotenuse. So as we did that, we get under root 3 by 2, cos of 60 is 1 by 2, and tan of 60 will be under root 3 because the perpendicular will be divided by the base. 2 and 2 will get cancelled with each other and only under root 3 remains. Now we found these three main trigonometric ratios, but we need to find their reciprocals. So the reciprocal of sine is cosec. So we can write cosec 60 will be equal to 2 over under root 3. It is the opposite of sine. After that, for sec 60, the opposite will be only 2, or you can say 2 over 1. Then for tan 60, the opposite is cot and it will be 1 over under root of 3. So this is how you can find the trigonometric ratios of 30 degree, 45 degree and 60 degree by using the help of a unit circle.